And we'll just jump right in. I'm really excited to introduce you to our first presenter, Dr. Matt Lease, who is serving as the Interim Associate Dean for Research in the School of Information, and is also a professor in the School of Information, and a executive team member of our Good Systems Leadership Group. So Matt is going to be speaking to you about responsible AI for science, assessing potential benefits versus risks. And I should have mentioned he's also the co-director of CosmicAI, and so he'll talk to you a little bit about that line of his research as well.
But yeah, so this is going to be a teaser, talking about AI for science, which has a lot of energy behind it right now, but thinking about what happens when we bring the issues of responsible AI into this context. Okay, so super briefly, what's AI for science, what's responsible AI, and then we'll talk about some of the benefits and risks we think about when we talk about AI for science. Okay, so as Leah was mentioning, a year ago we launched our second AI Institute. National Science Foundation funded. This one is jointly funded with Simons Foundation. 5-year AI Institute. This one's sort of thinking about AI, particularly in the context of astronomy. But all these institutes are this use-inspired research where we sort of say something about what are fundamental problems in the domain, be it agriculture, astronomy, education, that where we have AI gaps, how can we use those AI gaps to identify where we should really focus our AI effort and then solve problems in the domain and make AI better. So one of the things that we were particularly talking about doing when we launched this AI Institute was how could we accelerate discovery, And there's so much happening around this space right now. So the AI scientists got a lot of press a while ago where you just think about every step along the way that we scientists are used to doing manually. Now potentially AI can do it all. Great, you get rid of the scientists. And so like OpenAI is saying, for those of you who know how big 2025 was for AI in software engineering, automated writing code, that's what 2026 is going to be like for AI for science. We're going to basically be transforming the whole scientific process. So lots of talk and lots of hype around this stuff right now. So you hear this and think, AI is amazing. How can I get me some of that? Pesky problems once in a while that like autonomous driving runs into things, or projects don't work out the way we think, or gosh, it seems like every company and industry we look at in this space has gotchas where AI didn't quite work out quite the way it was planned. So what do we do? Responsible AI or AI governance is broadly the space that we think about these things. So several years back, our former president, Fenves, announced a big initiative here at UT, numbers something like 20 million that we've spent on trying to do across campus. We have over 130 active researchers across 30 departments, really thinking broadly about how we can make responsible AI. Broadly, how can we maximize the benefits that AI can bring us while minimizing the risks? So yeah, so here, AI for scientific discovery, why are we talking about this? Of course, we want to improve the speed of scientific work. Like, what are the benefits we can get now? In CosmicAI, we talked about CosmicAI is the name of our AI Institute for Astronomy. How can we take all these traditionally time-consuming aspects, such as processing large amount of data? Actually, a lot of the problems they have is just all the data is distributed, it's in different forms, it's hard to find it, you have to go get it, you have to assemble it. Like so much of what people spend a lot of their time on is data munging. And this is not even just in science. They did a survey of AI engineers at Microsoft. What are you? I'm an AI researcher. How do you spend your time? I spend 90% of my time cleaning data. But they associate themselves as being a modeler, not a data person. We really think there's this opportunity, this excitement that AI can really democratize science for anyone. So maybe anyone who has access to one of these cloud tools can start doing science, which sounds amazing. We can have these 24/7 online personalized tutors helping people get started. For people who aren't programmers, we can have these zero-code solutions. And we said in CosmicAI we really wanted to do this also to really transform access. A slide I cut for time is just universal translation. It doesn't matter what language you speak or read. We can take scientific results, translate them to any language in the world. Maybe that means not only can other people hear about the stuff that's getting published primarily in English, but maybe as people who only know English can learn a little more about what's happening in other parts of the world too. So amazing things that sound really exciting. But there's some potential risks too. And that's what we want to make sure we're thinking about. So I call this the usual suspects. Forget AI for science, just all the things we usually have to worry about with AI. Bias. Turns out the world's a biased place. We train AI on a biased world, and then suddenly we have the risks of AI systems being biased too. We have environmental impacts of AI. I think AI data centers are going to be the largest carbon producer in the United States in the next year or two, if not already. Ownership and liability issues. You can imagine if we're doing invention with science, who gets the credit when we discover something new? Who gets the blame when something goes wrong? It's really unclear when we have these sort of mixtures of AI and humans. And there's a lot of issues about shifting and concentrating power between sort of taking stuff away from lots of people and putting it in the hands of a few people who are producing this AI stuff. So that shows up a lot in the sense here, whether it's the powerful tech companies that get to do the research now, or the universities, the powerful universities, and not for everyone else. So the way we talk about democratizing AI, we actually have risks of the opposite. And workforce displacement. So, students could come in and wash test tubes and get started in science in some labs. Now, if AI is doing all the entry-level data tasks, entry-level like works getting started, how do they get started, in their scientific careers with us? So things we worry about, like lots of tools, when we accelerate science, we can accelerate it for the bad folks as well as for the good folks. So lots of bad stuff. And everybody, in the big tech companies is making guardrails, but guardrails don't help you if you have an open source model that you're running on your own computer and you can do whatever you want with. So there's real risks of that, of course. A project I lead within Good Systems, the Responsible AI Initiative here at UT, is looking at protecting the information environment, how we make sure as an information society we have reliable information. And now, basically when you use AI to generate papers, research, end to end, you can basically manufacture evidence to support any viewpoint you want and make it look like it's a real scientific paper. So you can basically drum up false support for things. Or you can basically say, here's a case where the scientific community is 100% agreed on something, but generate a bunch of stuff to make it look like there's division when there really isn't. In fact, a lot of what's going on right now is that the AI can produce lots of slop. There's lots of stories about this. Anytime right now your particular company, you give somebody a job they don't want to do, they're just going to get their AI to produce something that's good enough so they don't have to actually spend much time on it. This rise of AI slop. And so right now, the scientific community writ large is really under attack. And a lot of ways to make it look bad is generate a lot of slop and blame it on and say that's what the scientists are doing. In general, scientific work, we take a lot of pride in quality, reliability, trust. And so it's really important to us that the tools we work with in space are reliable. People are fallible, people make mistakes, but we really know through many, many years of science, how to deal with that. But AI tools are new. There's lots of problems where sort of mistakes can come in. A lot of times the mistakes seem very plausible, so they're hard to detect or notice sometimes when they happen. And then, of course, when you combine AI errors and human errors, you have all kinds of different kinds of errors that can come together. So for a field that really prides itself on, again, integrity, quality, reliability, these are big challenges when we have AI hallucination. In the fact-checking work, we've done a lot of work with journalists and fact-checkers, and same thing, that's one of the challenges they have in AI adoption is really having really reliable outputs. So I mentioned AI slop. There's an incredible rise of this stuff. So I just helped oversee one of the big AI conferences. We had 30,000 submissions this year, and every kind of adversarial thing you can imagine happens, from people putting white text in their papers because they know there's AI helping review process and trying to gamify the admission systems, people taking their same paper and automatically paraphrasing it into different forms of the same paper so they get multiple rolls of the dice when they submit for peer review. And there's systems like Archive where anybody can post something online, and so much slop is getting posted, they've had to basically change the rules to require now certain things can't get posted without peer review. So we're really struggling. Peer review is always challenging. Every time I submit a paper, it takes 3 or 4 people to review it. Now if we have 30,000 submissions, that means I'm looking at 120,000 human reviews I need for one conference out of many that are happening every year. So it's a real challenge for the field. And as I was mentioning, akin to journalism, when anybody can write stuff and put something online, how do we make stuff that's trustworthy? How do we keep scientific integrity going? So I'm going to have to stop in just a minute for questions. Let me see. Last things I guess to say is, the more we turn over to AI, there's a lot of fear that we're just going to basically create monocultures, a lot of sort of uniform, homogeneous stuff that all looks the same instead of the diversity of 1,000 garages of different scientific labs doing things in different ways. And we're also really worried about just erosion of skills. We know from various studies that people do less well at thinking, memory, analytical skills from increased reliance on AI. And the more that people delegate stuff to AI and aren't familiar with it, they won't actually know how the science is done, and that hands-on understanding might be incredibly important. So there's some risk of trading off short-term productivity gains, for sort of long-term skill and growth. There's also a notion that when we write a paper, there's a false sense of productivity. Like, papers don't matter. The question is, where are the important discoveries and breakthroughs? And we're seeing lots and lots of papers, but not really those breakthroughs like we want to see. So I'll leave, I think, with this last thing before I take questions. So Emily Bender is one of the people who has been outspoken among others. Is we're thinking so much about, like, oh gosh, AI is so great at writing for me. Let it write for me so that I can do the real work of science and not have to think about the writing. But the viewpoint is a misunderstanding of what science is. So much about what we actually know and understand comes through the writing process itself. I don't often know what I think about something until I try to reflect on it and put my ideas down on paper. When you automate that away, you lose a critical part of what's actually happening in science that makes it work. So we really need to think carefully about that. So just to wrap up, AI for science has great potential to accelerate science, but AI in general, we know in so many fields, brings risks as well as potential benefits. So we need to think about those risks and manage them early rather than just react after the fact. And so responsible AI for science is trying to think about how can we really maximize those benefits of AI for science while managing these risks.